Bismillahirrahmanirrahim. In this lecture, I am solving problem 3.45. This is basically 3.45 from the book Thermodynamics and Engineering Approach by Cengel 9th edition. So, in problem 3.45, statement is saturated steam coming up the turbine of a steam power plant at 40 degrees centigrade and given data. The steam coming out from the power plant at temperature of 40 degrees centigrade condenses on the outside of 3 centimeter outer diameter 35 meter long tube at a rate of 70 kilogram per hour. Condenses mean steam is initially dry saturated. I am explaining this on a TV diagram. So this is temperature and degree centigrade, and this is volume in meter cube per kg. This is saturation curve. Initially the steam is dry saturated at this position. Initially the steam at this position, and after condensation it is clear that it will be on the saturated vapor line, saturated liquid line. This is saturated. This line is called saturated vapor line, and this line, and this line is, this is saturated liquid line. So condensation mean after condensation it will be on this point. So this is the start point and this is the end point, and m dot is given to us as 70 kilogram per hour. Let we convert this into kilogram per second. So this will be equal to 70 kilogram, and 1 hour is equal to 3600 seconds. So m dot will be equal to 0.01944 kilogram per second, kilogram per second. And determine the rate of heat transfer from the steam to the cooling water when we condense the steam from point 1 to point 2. So find here rate of heat transfer to condense the steam. Find the rate of heat transfer to condense the steam from complete totally vapor to totally liquid. This is here the vapor is completely in vapor form, dry vapor, and here it is the working fluid is completely a liquid form. So find the heat transfer to convert from point 1 to 2. So here we know that when we convert liquid into vapor, it gain latent heat of vaporization, which is HFG. HFG is basically latent heat of vaporization. So when water from liquid form at its boiling point is converted to completely vapor form, it will gain latent heat of vaporization. So if we convert completely vapor to completely liquid form, so it will release this latent heat of vaporization. So Q dot will be equal to m dot multiplied by HFG. HFG is basically latent heat of vaporization. So find it from steam table. So from saturated steam table at temperature is equal to 40 degrees centigrade, find HFG from the steam table. So this is steam table, as in this temperature is 40 degrees centigrade, and this is basically HFG. This point, this is basically HFG. So find here HFG. So this is at 40 degrees centigrade, 2406.72, 2406.72 kilojoule per kilogram. So Q dot is equal to m dot HFG. M dot is 0.01944 kilogram per second, and HFG is 2406.72 kilojoule per kilogram, and this is basically 6. So this kilogram will be cancelled with this kilogram, and Q dot is equal to 0.01944 multiplied by 2406.2 is 46.0 7866 kilojoule per second. And we can also write this in the rounding up data. We can write this as 46.8 kilo, and joule per second is equal to watt. So this is the final answer. So these two both answers are correct, and this is the end of the problem. And for more problems, please like and subscribe my YouTube channel and share with your friends. Thank you.